the kind word of introduction. I would like to first thank the organizers for giving me this opportunity. It's always coming back home for me because I am native of this place. I think there are two relevant things that we had an association. One, we had a very informative session, inaugural session, where we got a lot of information and thought-provoking ideas. There was mention about retrofitting of the buildings, and I think some of you might have seen a book brought out by CPWD on retrofitting of buildings, which came 4 years back, and that has good tips for retrofitting of the buildings, though it is essentially meant for the reasons in the IS 1893 for the revised alphabet code, but it has general guidelines for retrofitting of various structural element, foundations, etc. We also had an association in addition to that regarding the DRIP program, where my colleague Professor K. Rajagopal organized a seminar in IIT Madras little while ago and a few months back, and we are also participating, advising several dams in southern India as part of DRIP, and we have been associated earlier that. So what I thought, I will be sharing some of my experience based on the inspection and analysis we carried out for some of the dams. These are particularly in Tamil Nadu, mostly belonging to Tamil Nadu generation. They have about 35 hydro power projects, and some are irrigation dams. Without taking much of your time, I will just go through the presentation. I'm sorry for some of the poor slides because we did not have a digital camera when these pictures were taken a few years back. This Vaigai Dam in Tamil Nadu, and as was mentioned earlier, that what has made the difference that the masonry structure in lime mortar is doing wonderful performance compared to the new structure. Even 5 to 10 year old dams we are seeing have a lot of leakage problem. This is done so good. I think one of the reasons is that the dedication to work which the people had those days, we don't find that could be one of the reasons in my view. Okay, I am not expert in masonry or concrete. I will be concentrating more on the earthen section of the dam, and as you see here, the earthen portion looks dry. Some of the earth dam don't support the grass turfing on the downstream side, which can lead to erosion if the soil selected is not appropriate. I will be just running through some of the dams downstream side first, where a good example of well-maintained downstream side with good healthy grass turfing. Well-maintained grass turfing, berms provided at a regular height interval with a catch drain so that rainwater don't have to continuously travel long and erode the surface, and you have a transverse drain leading the flow from the longitudinal drain to the rock toe and to the river, to this place. Just a closer view of it. Many times you have the drain, but the drain is choked with vegetation or with the sedimentation, and then instead of going into the drain, it gets overflow, and then you may have a problem of erosion. At the dam near Coimbatore, Aliyar Dam, also having a well-maintained downstream slope with the trains. Here the surplus is taking almost a 90-degree turn going parallel to the dam, and therefore this protection wall is provided to prevent erosion of the toe. Skip this. Yeah, this is another Kinnarsani Dam in Andhra Pradesh, which is essentially to supply the cooling water to the Kottagudam thermal power station in Andhra Pradesh. This had some distress of heavy seepage in the downstream side, leading to instability, and this is a later intervention by providing a filter layer and additional bulb here, which help in improving the stability. Highways Dam near Coimbatore again is around tree plantation in that area. This dam had a peculiar problem of differential settlement between the masonry section, which is resting on rock foundation, and the earthen portion, which is on the overburdened soil with varying thickness, and the differential settlement created a problem at the cracks at the shear key between the masonry section and the dam, but it has a similar feature on the downstream side as we discussed. This typical section of this highways dam, the red line indicates the present profile and the black line is the original profile. As you see, there is settlement over 40-50 years downward and slight bulging on the side due to the settlement of the dam. But the crack formed was essentially due to the differential settlement. I will show you a closer view of it. The dam had a carefully chosen core and the casing material with a generous slope. The normal design there has a steeper slope at the top and gradually made flatter at the bottom. Flatter slope in the upstream with stone pitching, revetment and grass turfing and bumps on the downstream side.